Okay, so here's where we were before.
Yeah.
We were looking for this limit, and we found when a, our constant a is e, this limit was equal to 1. But this limit came up because if f of x equals a to the x, then f prime of x was a to the x times limit as h goes to 0 of a to the h minus 1 over h.
Mm-hmm.
Okay. And for e, this was equal to 1. And it meant that the derivative of e to the x is therefore
The derivative of e to the x is just e to the x.
e to the x. And you saw that when this was equal to 2, when a equals 2, do you remember what this limit was exactly?
It was the log, or ln of 2.
ln of 2. So what's the derivative of 2 to the x?
It's 2 to the x ln 2.
That's right. So the derivative of a to the x, it turns out, is always going to be a to the x times natural log of a. So again, e to the x is, the derivative of e to the x is e to the x times log of e, which is
1.
1. And so that is one of the reasons why e to the x is such a very nice function. Its derivative at every point, x, slope of the derivative is equal to,
It's always equal to e to the x.
yeah, the slope of the derivative is actually equal to the value of the function. So what's the slope at x equals 0?
0. No, e to the 0, 1.
1. Where is the slope 0?
At negative infinity.
Yeah, negative infinity. So so that's, you know, a quick and dirty of how you derive that the derivative of e to the x is e to the x. It's actually sort of a surprising approach. We've just defined e to be the number such that e to the x has a derivative equal to
e to the x.
e to the x. That's what e. So that's one way of defining e. There are several other ways of defining e. And before the year's over, we'll learn that these are all the same. So e to the x, one definition of e is e to the x prime equals e to the x. That's the definition we just used. Another definition of e is 1 plus 1 over 0 factorial plus 1 over 1 factorial plus 1 over 2 factorial plus 1 over 3 factorial. Third definition is e equals the limit as n goes to infinity of 1 plus 1 over n. The n. It's surprising that these are all the same number.
Mm-hmm.
So, but anyway, that's exponential functions. You think you could derive that on your own now?
Maybe.
Maybe? Okay, well, cool. Alright, good job tonight, huh?